We have another work example on our series, which is logarithmic differentiation. Find the derivative of y is equals to x to the power of x. Now, to solve this question, the first step is that we are going to take the natural log of both sides. So for this, I'm going to have the natural log of y is equals to the natural log of x raised to the power of what? X. You understand? So don't forget that if I have y is equals to a raised to the power of b, if I take the natural log of y and take the natural log of a raised to the power of b, the natural log of y can be equals to what? B natural log of what? A. You understand? So I'm going to apply the same principle in this place. So let's proceed. I'm going to have the natural log of y is equals to the natural log of x. Don't forget that according to this principle, according to these rules of natural logarithm, the power will multiply the coefficient. You understand? So I'm going to have this will come to this. I'm going to have x natural log of what? X. You understand? Okay. Now I want you to remember, we are going to take the derivative of the left hand side and the right hand side. Are you getting it? And don't forget, if we take the derivative of y is equals to the natural log of x, the derivative of y is what? We are going to take the inverse of the function inside the bracket. So I'm going to have the inverse of x multiplied by what? The derivative of x. If I differentiate x, this is derivative, okay? If I differentiate x, I'm going to have 1. So the derivative of y is equals to what? 1 all over x. You understand? So now I'm going to use the same principle in this place. Take the derivative of natural log of y. I'm going to have the derivative of the inverse of y, which is the inverse of the function inside the bracket, multiplied by the derivative of y. This is derivative. This is also the same thing as what? The y all over the x. You understand? So I don't want to write it in full. That's why I represent it as this. Okay. Now let us take the derivative of the right hand side of this equation. You can see that we have two functions that are multiplying each other. We have what? X multiplied by natural log of x. Is that not it? That's it. Now I will make use of product rule in this place because I have two functions. This is one part and this is another part. This is one part and this is another part. And according to product rule, when we have y is equals to uv, derivative of y is what? Derivative of u multiplied by v plus the derivative of v multiplied by what? U. You understand? Now, if you compare this, the right hand side of this equation with this, I can say that y is equals to x ln x. You understand? Let me put it. Y is equals to x ln x. You can see I just bring this left hand side, I bring it out. You understand? So if you compare this with this, u is what? U is what? X. And v is what? Natural log of x. Please don't be confused. I just bring the right hand side of this equation, I bring it out so that I'll be able to differentiate it using the product rule. Are you getting it? Now let us take the derivative of y. Derivative of y is equals to derivative of u, which is x. If you differentiate x, you are going to get 1. Abi? Multiplied by v. V is what? Ln x. So I'm going to have multiplied by ln x plus the derivative of v. If you differentiate v is what? Ln x. If you differentiate ln x, you are going to get 1 all over x. 1 all over x. Multiplied by u. U is what? X. So I'm going to have x in this place. So the derivative of y is equals to 1 multiplied by ln x. That is ln x plus 1 all over x multiplied by, let me put product sign. 1 over x multiplied by x, that is x over x. X over x is what? 1. So that is plus 1. So the derivative of y is equals to x ln x is what? Ln x plus 1. So I have already taken the derivative of the left hand side. So if I take the derivative of this right hand side, I'm going to get what? Ln x plus 1. So I'm going to put it here. Ln x plus 1. The next step is to multiply both sides by y. Okay. The next step is to multiply both sides by y. So I'm going to have y multiplied by this, multiplied by y. So this y will cancel this y. So I'm going to be left with the derivative of y is equals to y multiplied by natural log of x plus 1. You understand? And don't forget that y is equals to x raised to the power of x. Y is equals to x raised to the power of x. So the derivative of y is equals to x raised to the power of x multiplied by ln x plus 1. You understand? So the derivative of y is equals to x raised to the power of x is what? X raised to the power of x into bracket ln x plus 1. Question number 2. Find the derivative of y is equals to 2x raised to the power of 2x. You can see that this question is synonymous to what we just did the other time, which is what? Y is equals to x raised to the power of x. We are still going to use the same approach. The first step is to take the natural log of both sides. So I'm going to have natural log of y is equals to the natural log of 2x raised to the power of 2x. You understand? Okay, after this is the first step. The next step is that if we have y is equals to b raised to the power of a, the natural log of y can be written as what? Natural log of b raised to the power of a, and this can be written as what? Natural log of y is equals to a natural log of what? B. You understand? So I'm going to use the same approach here. So for this, I'm going to have the natural log of y is equals to 2x natural log of what? 2x. You understand? Okay. Having done this, I'm going to differentiate the left hand side and the right hand side according to the previous example that we did. So I'm going to have, if you differentiate the natural log of y, I'm going to have the inverse of the function inside the bracket multiplied by the derivative of that function. You understand? Which is this. Differentiate the left hand side, I'm going to have, using the product rule, as you can see that this part has two parts. The right hand side has two parts. The first part is what? 2x, and the second part is what? The natural log of 2x. So I'm going to use product rule. Okay, now let's proceed. To differentiate this using product rule, I'm going to have the derivative 2x multiplied by derivative of v, which is ln 2x. So I'm going to have 1 over 2x multiplied by 2 plus ln 2x multiplied by the derivative of 2x, that is also 2. You understand? That is u, this is u, dv, differentiates ln 2x, you are going to get this, plus v, which is ln 2x, du, differentiates 2x, you are going to get 2. You understand? If you don't know how to solve, if you know how to differentiate using the product rule, you can go back to the channel and watch the video. You understand? So now let us proceed. Natural log of y multiplied by the derivative of y is equals to 2x multiplied by 1 over 2x multiplied by 2. That will give us 4x all over 2x. 4x all over 2x plus 2 ln x, 2 ln 2x rather. You understand? Okay, let's proceed. For this, I'm going to have 1 over y multiplied by the derivative of y is equals to 4x all over 2x. That is 2. 2 plus 2 ln 2x. You understand? Okay, now the next step is that I'm going to multiply both sides of this equation. I'm going to multiply it by y. You understand? So I'm going to have y multiplied by derivative 1 over y multiplied by derivative of y is equals to, I'm going to multiply the right hand side also with y. So I'm going to have y multiplied by 2 plus 2 ln 2x. You understand? Okay. The reason why I multiply both sides of this equation by y is because I want to eliminate y, which is at the denominator of this fraction, which is 1 over y. So for this, I'm going to have y will cancel y. So I'm going to be left with 1 multiplied by the derivative of y. So the derivative of y will be equals to what? Y into bracket 2 plus 2 ln 2x. You understand? Okay, don't forget that from our equation, y is equals to 2x raised to the power of 2x. Y equals to 2x raised to the power of 2x. So the derivative of y is equals to 2x raised to the power of 2x into bracket 2 plus 2 ln 2x. You understand? So you can leave your answer like this or open the bracket. For simplicity, I'm going to leave my answer like this. You understand? So the derivative of y is equals to 2x raised to the power of 2x is what? 2x raised to the power of 2x multiplied by 2 plus 2 ln x. So that is how to find the derivative of a function that looks like this. Now let us proceed to the third question. Find the derivative of y is equals to 5x raised to the power of 5x. You can see that this question that we are solving is kind of related to each other. We are still going to use the same approach. The first step is that we are going to take the natural log of both sides. So I'm going to have the natural log of y is equals to the natural log of 5x raised to the power of what? 5x. You understand? Okay. The natural log of y is equals to 5x multiplied by the natural log of 5x. You understand? According to this rule, the power will multiply the coefficients having applied the natural log. Okay. Now the next step is that I'm going to take the derivative of what? Both sides. So I'm going to have natural log of 1 over y multiplied by the derivative of y is equals to, take the derivative of the right hand side, which is 5x ln x. If you take the derivative of this right hand side using the product rule, you are going to get 5x multiplied by derivative of ln 5x. Derivative of ln 5x, I'm going to have 1 over 5x multiplied by 5 plus ln 5x multiplied by, if you take the derivative of 5x, I'm going to have 5. You understand? I used the product rule to differentiate the right hand side. You understand? So if you didn't know how to differentiate using the product rule, you can go back to the channel and watch the video. You understand? Okay, now let us proceed. Now, having differentiate both the left hand side and the right hand side, the next step is that I'm going to multiply both sides by y, so that I will be able to eliminate this this y. You understand? So I'm going to have multiply both sides by y, multiply both sides by y. The derivative of y, this y will cancel this y. You understand? So I'm going to have the derivative of y is equals to 5x multiplied by 1, that is 1, 5x. 5x multiplied by 5, that is 25x. So I'm going to have 25x all over 5x plus, okay, 5 multiplied by ln 5x. So I'm going to have 5 ln 5x. You understand? So I'm going to multiply both sides by y. You understand? Okay, let's proceed. The derivative of y is equals to 25x divided by 5x. That is what? 5. You understand? So I'm going to have derivative of y is equals to 5 plus 5 ln 5x. 5 ln 5x multiplied by y. And don't forget that y is equals to 5x raised to the power of 5x. So y is equals to 5x raised to the power of 5x. So the derivative of y is equals to 5x raised to the power of 5x, which is y. I substitute the value of y as what? 5x raised to the power of 5x. You understand? So 5x raised to the power of 5x multiplied by the entire quantity in this bracket. So I'm going to have 5 plus 5 ln 5x. You understand? So the derivative, you can leave your answer like this and you can also expand. You understand? But for the sake of simplicity, I will prefer the answer as this type. You understand? So the derivative of y is equals to 5x raised to the power of 5x is what? 5x raised to the power of 5x multiplied by 5 plus 5 ln x. You understand? Okay, so I want you to try this. We have done 3 examples now, Abby. We have done 3 examples. I want you to try this question 4. Question 4. I want to try this. Differentiate y is equals to 3x raised to the power of 3x. You are going to use the same approach. You can try this and drop your answer in the comment box. I'm going to attend to it. Thank you very much for watching the video. And I would like you to subscribe to my channel and also follow me on my page. Follow my page on Facebook, Beloved Academic.